Welcome. We want to take a quick look at different ways to present our final answers when we have polynomial division. Let's consider, for example, we wanted to take x cubed minus 2x plus 1, take this polynomial and divide it by x minus 3. Now, usually when we write it in this way, if I say this divided by that, of course, what I'm going to want to do is I'm going to want to write that the final result, right? So you perform the long division or you perform the synthetic division, whichever the case may be, and you're going to find that that is x squared plus 3x plus 7 plus, right? So you end up with this polynomial plus you have some remainder. That remainder is 22 in the division. So you have 22 divided by x minus 3. And this is fine, right? If I wanted to write it in this way. But oftentimes, what we actually want to do is we want to use this, what's called, let's see here, the division algorithm. Now, that's a fancy name, and usually it's only applied to dividing numbers. But what we want to recognize is we can find a presentation for this. So oftentimes what we're given is some polynomial p of x, and we want to divide it by some other polynomial, the divisor d of x. When we do that, we're going to end up with the quotient. So oftentimes this is referred to as q of x. And this remainder, just the numerator here, this is often called r of x. So sometimes you'll see directions that look like divide p of x by q of x and write in the form p of x is equal to q of x times d of x plus r of x. Now, these instructions, of course, look a little bit different and a little bit weird than maybe what you've seen, but really all that they're saying is they want you to take this particular presentation that we've already said, hey, yeah, that makes sense. When we divide, we get some quotient and some remainder. But what we're going to do is we multiply both sides by d of x. When we do that, it cancels out with this division of d of x, so p of x is equal to, and then we distribute q of x times d of x, and then this, of course, is d of x itself. So when we multiply, we're again getting rid of that, and we're just left with the remainder. So this is an equivalent form. Again, to be clear, if we take p of x and we divide it by d of x, what we get is some quotient, and then we have some remainder still divided by that divisor. If we multiply both sides by d of x, then we get exactly the p of x, and then multiply. All right, so when we multiply by d of x over here, multiply by d of x over here, cancellation, distribute, and we get q of x times d of x. Distribute, we get cancellation plus r of x. So in the specific example that we gave here, we could say that x cubed minus 2x plus 1 can be written as x squared plus 3x plus 7 multiplied by x minus 3 plus 22. So there are different ways to present the answers. Now, I didn't perform the polynomial division in this case, but I wanted to be able to just discuss the presentation. So we have this presentation. You'll see that sometimes. And we have this presentation. You'll see that sometimes. This particular presentation is my personally preferred presentation, though again, sometimes in the homework, they'll ask for the other. The reason that I prefer this notation is because it highlights better for what we will later call the remainder theorem, let's see here, and the factor theorem. Those are both results of considering this particular presentation in polynomial division.